physics, hot, 134. Section summary. Ohm's law for a conductor at constant temperature, current in the conductor is proportional to the potential difference across it. The resistance of a metallic conductor increases with increasing temperature. The resistance of a semiconductor decreases with increasing temperature. A diode has a low resistance when connected in forward bias and a very high resistance in reverse bias. Resistivity of a material is the resistance between opposite faces of a unit cube of the material R, which is equal to Pi over A. Section questions. Number 1. The element of an electric kettle has resistance 26 ohms at room temperature. The element is made of nichrome wire of diameter 0.6 millimeter and resistivity of 1.1 × 10⁻⁻⁶ megameter at room temperature. Calculate the length of the wire. Number 2, these are the values of the current through an electrical component for different potential differences V across it. Draw a diagram of the circuit that could be used to obtain these values. Calculate the resistance of the component at each value of the current. Plot a graph to show the variation in current of resistance of the component. Suggest what component is likely to be giving a reason for your answer. The current in a 2.50 meter length of wire, diameter 1.5 millimeter, is 0.65 ampere, when a potential difference is 0.40 volt is applied between its end. Calculate the resistance of the wire. Calculate the resistivity of the material of the wire. Electrical circuits. At the end of this section, you should be able to recall and use appropriate circuit symbols to interpret and draw circuit diagrams. You should be able to recall Kirchhoff's first law and appreciate the link to conservation of charge. You should be able to define EMF in terms of the energy transferred by a source in driving unit charge around a complete circuit. You should be able to distinguish between EMF and PD in terms of the energy consideration. You should be able to recall Kirchhoff's second law and appreciate the link to conservation of energy. I beg your pardon, please. You should be able to show an understanding of the effects of the internal resistance of the source of EMF on the terminal potential difference and the output power. When reporting an electrical experiment or describing a circuit, it is essential to know exactly how the components are concerned. This could be done by taking a photograph, but this has disadvantages. The photograph on page 167, for example, is not clear, does not show all components. Besides, you may not always have a camera with you. You could sketch a block diagram in which the components are indicated as rectangular boxes labeled cell, ammeter, resistors, etc. The blocks would then be connected with lines to indicate the writing.
బాధలు వాడుకుంటాం.